Dark script presents linear equations with fractions. Algebraic fractions represent numbers, just that you do not know what numbers they represent at the beginning of the problem. You can pretty much do all the math operations on them just as you could do with numbers. For example, add, subtract, multiply, divide, find the LCM, find the greatest common factor, and so on. And therefore the steps to solving these equations are pretty similar to what you would do on equations without fractions. Get all the terms with the unknown on one side of the equation and the constants on the other side. Collect the like terms and an additional step of getting rid of the denominators and then solving for the unknown. Let's see a few examples at work. Let's say we have 5 plus 3 over x. So x is the denominator of this fraction, is equal to, on the other side, let's have 4 times x plus 4 all over x. But there can be different approaches to solving this problem, or at least the first step. And the path I'm going to take is about getting rid of these fractions by multiplying both sides of the equation with the least common multiple of the denominators. Now, if you look at the denominators, there's an x here, there's an x here, and there's nothing under the 5. So we can always think of it as 5 over 1. So there's a 1 here. And the LCM of 1x and x obviously is x. So what I'm going to do is, I'm going to multiply this side with x, all of that, and this side with x, all of that. So on the left hand side, in the next step, we're going to distribute this x on the two terms. So we have x times 5, which is equal to 5x, plus x times 3 over x. Now, if you think about this, x times 3 over x, this x and this x cross off. You have a 1. And therefore, effectively, there's just a 3 out there. And in the same way, if you look at the right hand side of the equation, this x out here crosses off with this x, because this is one whole single term, 4 times something over x. Don't get confused with this plus sign because it's inside a parenthesis. Think of this as, like I said, 4 times something all over x. So this x and this x pretty much cross off, and we just have a 4 times x plus 4, and the 4 can be distributed on the x and the 4, let's say on the next step. So we have 5x plus 3 is equal to 4x, 4 times x, plus 4 times 4 is 16. Time for us to get all the x's on the left and all the constants on the right of the equal sign. So to do that, we want to take this 3 on the other side. So get rid of the 3 from here, subtract 3. Now, if we are subtracting 3 from one side of an equation, we have to do it on the other side as well. And then also, get rid of this 4x by subtracting 4x. 4x minus 4x is 0. But if we do it on this side of the equation, we need to do the same thing on the other side. Subtract 4x. Therefore, 5x minus 4x is 1x or x. These two cross off. There's a 0. Is equal to, these two cross off. There's a 0. 16 minus 3 is 13. The answer is x is equal to 13. Let's look at another one. X plus 5 over x plus 3 is equal to x minus 4 over x plus 5. Fractions on both sides, and there's a reason I left some space out here. You'll get to know soon. If you're aiming to get rid of the two denominators, you have to make sure that you multiply this side of the equation with x plus 3 so that this and this cross off, and this side of the equation with x plus 5 so that this and this cross off. But you're not allowed to multiply two sides of an equation with two different quantities. They have to be the same quantity. And therefore, you decide that, okay, I'm going to multiply both sides with x plus 3 times x plus 5. So I'll keep both. Fair enough. This is allowed. And in the next step, we could rewrite that. This is gone, that's a 1. This is gone, that's a 1. So we have x plus 5 times x plus 5 is equal to x minus 4 times x plus 3. And then we can open the parentheses up on both sides by applying FOIL. First, outer, inner, last. X times x is x squared plus x times 5, that's 5x, plus 5 times x, that's also another 5x, and finally plus 5 times 5, that's a 25. On this side, x times x, that's a x squared, x times 3 plus 3x, minus x times 4 or minus 4 times x, that's negative 4x, and finally negative 4 times 3, that's negative 12. We have an x square here and an x square here. But in a linear equation, the highest power or the exponent of the unknown is 1. So what's going on? Well, it's pretty easy to get rid of these two x squares by simply subtracting x squared from both sides. They're gone. This is gone and this is gone. So that in the next step we have 5x plus 5x. Let's just combine those two like terms. We have a 10x plus 25 is equal to, on the other side, 3x minus 4x. That's a negative x minus 12. Bring the 25 over to this side. Bring the negative x over to this side by subtracting 25 from both sides. So you do a minus 25 on both sides and adding x to both sides. So that these two cross off, you have a 0. These two cross off, you have a 0. And we have 10x plus x, that's 11x, is equal to negative 12 minus 25, that's negative 37. One final step, this is 11x or 11 times x. Therefore, to find x, you divide both sides with 11. So we have x is equal to negative 37 over 11, and that cannot be simplified. So that's x. Maybe you could change it to a mixed number and go on to say that, okay, this is equal to 11 times 3 is 33. So negative 3, the remainder is 4, negative 3 and 4 11th. That's also right.